Today we're going to talk about an idea so big, so powerful, that some people, like the philosopher Daniel Dennett, think it might just be the single greatest idea anyone has ever had. And we're going to unpack why, thanks to the thinking of Richard Dawkins. So what is this incredible idea? Let's get into it.
I mean, just think about that for a second. That is a huge claim. We're not just saying it's a great idea in biology. Dennett is putting Darwin's idea above Newton's laws of motion, even above Einstein's theory of relativity. So what on earth did Darwin figure out that could possibly earn that kind of praise?
And that's really the big question we're tackling today. To even begin to answer it, you first have to appreciate the sheer scale of the problem Darwin was trying to solve. It's a problem that is literally all around us, in every single living thing you can see.
Right, so before we even get to the idea itself, we have to understand the mystery it unlocked. And that mystery is the absolutely staggering, almost unbelievable complexity of life. It's why biology is even a thing, right?
From the smallest bacterium to the biggest blue whale, every living thing is this marvel of intricate engineering. As Richard Dawkins puts it, evolution is the only explanation we have for the astounding complexity and beauty and elegance that just fills our world.
So, this is the fundamental question. Why isn't everything simple? Why do we see these incredible, elaborate, Rube Goldberg-like designs everywhere we look in nature? Well, Dawkins argues that life has to be complicated. It has to be complicated just to survive. Let me show you what I mean with a couple of examples. You know, people talk about chameleons changing color, but that's slow motion compared to this. Dawkins points to the cephalopod. We're talking squid, octopus, cuttlefish. Their skin can change color almost instantly with so much detail and precision, he calls it a high-definition biological TV screen. And what's wild is just how literal that analogy is. You know how your TV screen uses pixels of red, green, and blue to make every color imaginable? Well, a squid's skin uses millions of tiny little sacs of pigment, red, yellow, and brown. It's basically the same system, but it's biological. It's nature's version of our own technology. And this is where it gets just mind-blowing. They have such fine-tuned control that a male squid can send two completely different signals at the same time. One half of its body can be flashing a bright white pattern to attract a female, while the other half is a drab, camouflaged brown to hide from predators. It's instantaneous and absolutely perfect.
And if you zoom out, you see this kind of complex coloration is mission-critical all across the animal kingdom. It's a language, really. You've got the yellow and black stripes of a wasp. That's a warning signal. You've got harmless flies that mimic those same stripes to trick predators. Color is how you survive.
And of course, it's not just about color. Take the chameleon's tongue. It's not just a tongue, it's a biological harpoon. It fires out with incredible speed and accuracy to snatch an insect right out of the air. I mean, this is some seriously high-level engineering. So how does stuff like this even come to exist?
Well, according to Dawkins, the engine that drives all this incredible complexity is something he calls an evolutionary arms race. And yeah, it's pretty much exactly what it sounds like. A direct parallel to the military arms races we see in human history.
It's this relentless, escalating cycle. Think about predators and prey, or parasites and their hosts. They're locked in this struggle that lasts for millions and millions of years, where each side is constantly forced to one-up the other just to stay in the game.
Okay, so here's how it works. It's a cycle that feeds itself. A cheetah evolves to be a little bit faster, which means only the fastest gazelles survive to have babies. Well, now you've got a population of faster gazelles, which means only the fastest cheetahs can catch them and eat. Over generations, this back-and-forth pressure forges more and more sophisticated, more complex animals on both sides. Okay, so we've got the problem, this dazzling complexity, and we've got the engine that drives it, the evolutionary arms race. But who is the first person to actually put all the pieces together? Well, that brings us to the history of the idea itself.
Now, here's a really important distinction. The idea that life changes over time, that it evolves, that wasn't new. Even Darwin's own grandfather wrote about it. The massive breakthrough, the revolutionary part, was the mechanism. It was how it all worked, natural selection. And unbelievably, Darwin wasn't alone. A younger naturalist named Alfred Russel Wallace came up with the exact same idea completely independently.
So, in 1858, papers from both Darwin and Wallace were read out loud at a meeting in London. And you know what happened? Basically nothing. Crickets. It just didn't land. It wasn't until a year later, when Darwin finally published his masterpiece on the origin of species, laying out the entire argument with mountains of evidence, that the world finally sat up and paid attention.
And this brings us right back to our original question. What makes this idea so special, so great? Well, the answer is kind of a beautiful paradox.
Think about this. When Isaac Newton came up with his laws of motion and gravity, he literally had to invent an entirely new kind of math, calculus, just to make it all work. It was profoundly complicated. Darwin's idea, on the other hand, is just stunningly simple. There's no fancy math. It's just an elegant, logical process.
And this, Dawkins argues, is why it took so long for anyone to figure it out. I mean, when you look at something like the human eye, or a squid's skin, it seems so overwhelmingly complex, your first thought is that the explanation must be just as complex. It took some serious intellectual courage for Darwin to stand up and say, no, actually, I think a very simple, natural process can explain all of this.
And that's the heart of it right there. That's its greatness. You have this beautifully simple idea, natural selection, that has enough explanatory power to account for the almost infinite complexity and diversity of every single living thing that has ever existed on this planet. It is the ultimate elegant solution.
So that's why Darwin's idea stands so tall. It's a powerful reminder that sometimes the most profound truths are hiding behind the simplest explanations, which kind of leaves us with a final thought to chew on. What's the simplest idea you know that explains the most? Thanks for watching.